Good afternoon. My name is Reese Hancock, and I've been the project manager of our senior design group this past summer. Our group title has been called Following Your Lead, a motion replicating servo robot. And this is mechanical system design for the summer 2025 at Georgia Southern. I would like to give you a brief introduction of how this presentation is laid out. I have an About Me slide, team organization and leadership. I introduce the topic. I have an executive summary, a system overview. I have an overview of what I was able to do for weeks 1 through 4, a future work slide, conclusion, and some acknowledgements. So a little bit about myself. I'm currently a senior in mechanical engineering at Georgia Southern University. My hometown is Sylvester, Georgia. My hobbies include hunting and fishing. I'm also a pianist. I've been playing piano since I was 7 years old. And my future plans are to begin at Georgia Power Company as a test engineer at the Statesboro location as of July this year. So first thing I'd like to do is explain how I was able to subdivide all the work this semester. So again, my name is Reese Hancock, and I've been the project manager for the summer. I was able to create a support and marketing team, which has been led by Jackson Hurst. His group members have been Carson Tudor, Dalton Cohn, and Jake Thomas. The hardware improvement team has been led by Graham Corliss, and his subgroup members are Alana Martin and Bryce Cohn. And the software and coding group has been led by Luke Palmer, and he has had help from Darrell Hanna and Eliangel Martinez Reyes. So to introduce the entire topic, this is Groovy. Our team was actually able to develop Groovy, who is able to replicate a human's movements through the integration of a Raspberry Pi 5, a Google Coral, a Raspberry Pi camera, and 2 servo motor driver boards. And this robot Groovy is a great example of how we as students have been able to combine mechanical and electrical systems through post-estimation software. For an executive summary, this project, which I've been able to lead, combines a Raspberry Pi 5, a Google Coral, and a Raspberry Pi camera to run a post-estimation system. And that post-estimation system then sends a signal to servo motors through 2 PCA controller boards, and then that controller board is able to replicate the human's movement on the robot itself. So my specific role this summer in this project has been able to coordinate each subgroup and ensure that all of our short-term and long-term goals were met, as well as making sure that each leader and each member of our groups had the resources they need to get the things that they needed to get done. I've been able to plug in as the leader to all 3 of these groups, and really I've been able to communicate with them well and dive into the technicalities and the details of this robot itself and how all these systems work together. And as project manager, I've also been responsible for briefing Dr. Choi and letting him know the progress of everything throughout the semester and keeping him updated on everything that's going on. So for a quick system overview, this is a good example and a good demonstration of how the whole system works. So you see on the bottom left, you have me, and I'm just doing a simple arm out movement here. That is sent to the camera, which then sends the image transfer to the Raspberry Pi 5. The Pi 5 then sends the signal to the Google Coral, which then goes back to the Raspberry Pi 5 after the Google Coral has accelerated it. This data mapping system is then transferred to the PCA motor board. The board then sends the signal to the controllers themselves, and each controller moves accordingly, and the robot is moving just as I am. So for a brief overview of week 1 and my roles during week 1, the first step for me was to create and organize the leadership for each group. So I was able to coordinate the hardware team to begin printing the robot from Thingiverse software, and also was able to coordinate the group to assemble the Raspberry Pi 5 in its respective case. And shout out to that team because the robot was fully assembled on day 2, so that's great. We were able to really speed that process up. And through this process, I was actually also able to coordinate the software and coding team to begin researching the Raspberry Pi 4 and how the Pi 4 system works. And all of us were very inexperienced with the operating system on the Raspberry Pi 5, and we used this time during week 1 to learn and research and learning exactly how these systems work, which was very helpful for week 2. So here you see on the right, we have the printed robot, which our hardware team was able to do on day 2. And then also we have the Pi 5 that's currently being used now with its Google Coral. So these are the 2 main systems of our project, which was done by week 1. So that was great. Week 2, I was able to actually work directly with the hardware improvement team to do 2 different things. The first thing I was able to do was test each individual servo motor, defining a neutral point and its specific range of motion. That's very, very important. Once we did that, I was also able to assign an address for each motor based on its location and its orientation on the robot itself. I was also able to coordinate and assist the software encoding team with object detection and pose estimation. Object detection was huge, and we actually had Luke get that running for us. The progress was very slow, but it took a lot of time and a lot of blood, sweat, and tears and a lot of learning to get that right. And we also used Pi 4 and Pi 5 devices to learn throughout this entire process. So you see on the left here we have the picture that Graham Corliss and I were able to develop. You see here the servo motor on the head corresponds to 1, 0, which means board 1, channel 0. And we were able to actually define a specific address and describe that address based on a specific location here. So you see we have the head, the right shoulder, and everything on the right side was on board 1, and then everything on the left side was on board 2, starting from channel 0 and going down to channel 8, down the body. And you see I was able to also define a specific range of motion for each one of these servo motors. So the neutral point for the head was when the head is pointed straight, and then the actual human is able to look to the left and to the right. So you see we had the head pointed left here, and the head pointed right, and using those the values that we were able to develop for each motor was very helpful when we were able to integrate that into our main system. Week 3. In week 3, I was able to work directly with software encoding to get the pose estimation running as fast as possible. We were all struggling pretty hard, and we were running out of time, so we kind of all dived into that together. This required several packages from the internet, several different models from the internet, as well as a detailed code to run that was generated through artificial intelligence. Through everything we learned in weeks 1 and 2, we were able to learn about the virtual environments that are included in the Pi 5, and also understanding the file directories and knowing which files are in which location and how to reference them in the code. We also, during week 3, we were able to successfully, through the hard work of the software encoding team, we were able to successfully run pose estimation and got that running well. And through that successful run, we were able to integrate the human movements to the robot's head and to its right arm. And I was also able to coordinate the support team to use what we developed on one Pi 5 and duplicate that on another to make sure we had a backup in case something happened. On the right here, you see the successful pose estimation run. And then you see just a simple left arm movement in the air that's being replicated by Luke as it's happening in real time. So week 4 was kind of a continuation of week 3. I kept working really, really closely with the software encoding team to continue adding servos to the pose estimation system. We had quite a few issues this week, and specifically we had a broken driver board. We had to get that replaced and resolder all those connections. The servo accuracy is still a little off, so the angles aren't quite where they need to be. And also we have very little knowledge about Python and its operating system. So that's been a huge challenge this week. But all that's been overcome, and we were able to finish the project this week, which is great. I also coordinated the marketing team to create the brochure and the commercial and get all those things rolling before Milestone 3 presentation. We're currently in preparation for Milestone 3, which includes our group report, our final presentation, and the brochure and the commercial and all those good things. So before then, I'm still continuing the leadership roles. We're finishing the project up quickly and smoothly, and we're almost there. So again, for week 4, as of today, all 4 arm joints work and they are functional and smooth. The head joint works well, and also both lower hip joints work as well. So you can see the pictures here. The robot is doing exactly as I am. The upper torso is working well, and then we have the full legs move out and in based on a 2-dimensional coordinate system. So for some future work, for future engineers who may work on this project, it may be a good idea to figure out how to successfully integrate 2 PCA boards using an Ethernet cable rather than Wi-Fi for internet to speed this process up. Had a very hard time with hardware this semester, so our power supply cords, the communication pins on the Raspberry Pis themselves, and also loose screws were huge issues this semester. So using better hardware is a huge, will make things much quicker and much faster. And it'd also be a good idea to research Python and figure out how the systems work before you start working on this project. So overall, to conclude, the group that I've had the opportunity to lead has been great. We were able to successfully complete this project in the time we were given. Not all 19 of the motors move, but most of them do, which is a huge success, and they all move smoothly and accurately. We've had a very hard time this semester, and we've all learned an astronomical amount. But me specifically, I've learned a lot about programming, about logic, about leadership, and also about Python scripts in these four short weeks. And again, the knowledge I've gained this semester will be very, very helpful for my engineering career in the future. Some special acknowledgments to Dr. Choi. Thank you to our professor. He's been great and been very helpful this semester. I'd also like to shout out Dr. Brian Velchek, our department head in mechanical engineering, and also a special thanks to the department of mechanical engineering here at Georgia Southern. I'd like to quickly just give a brief reference slides of the resources we use this semester, just some packages online, some different files we use for help, and our Thingiverse software to download the robot itself. And then just some more references. So, good afternoon and thank you.